But I mean, going beyond planets, I find that that's fine, but that's a bit like botany. What you really want to do is to try to find life forms, right? So I don't know, maybe people have talked a lot about looking for evidence of water vapor in the atmosphere of exoplanets as indicative of the presence of oceans, perhaps. I've always been a bit confused by this because it seems to me that volcanic activity can produce a lot of water vapor, either directly or indirectly. And so how on earth, if you find something like that, do you think you can relate that to life?
So I think that it will be hard to convince everybody that you have found life just by looking at biosignatures. Biosignatures are these things that we think are produced by life, and you have to find a number of them. So ones that have been suggested and I think are reasonable is, yes, you want to find water in the form of water vapor because you will not see directly the water on the surface, but if there is a high abundance of water vapor, this probably indicates that there is some liquid water on the surface as well. Oxygen is another one that is strongly talked about, especially in high quantities. I mean, you can form oxygen in other ways. For example, by very intense UV radiation, you can split CO2. People have shown that, and so you get oxygen. But to get very high concentrations of oxygen, in the tens of %, let's say, is hard, and we know that life can do that. But most importantly, you want to find a whole collection of biosignatures. For example, oxygen in the presence with some reducing things like methane, let's say, which normal chemical equilibrium conditions cannot form, but life forms can, are thought to be a good argument. So if you find, also there is the issue of the planet needs to be old enough, because if it's very early, like in the very early Earth, you would not have seen that there is life there. So suppose you find a planet that is old enough, it's in the habitable zone of its parent star, you find large amounts of water in the atmosphere, you find oxygen, you find conditions that are in thermochemical disequilibrium, like also methane, other things, and so on. And you find a combination of these. It would be great if you actually can see chlorophyll too, but that's hard to see. But suppose you find all of these, then you will start to make a case that maybe you have seen a place where life was able to change the atmosphere of that planet. And I'm talking at this point about primitive life, yes? I mean, bacterial life or things of that nature. Will you be absolutely convinced that you have found life? I don't think so. But you will have to be able to make a strong case the more of these biosignatures you find.
Right, okay. So let's suppose that we manage to find some candidates someday, and it seems to me that, even thinking of the largest future telescopes being planned today, we might have, maybe in the next 20 or 30 years, identify 10, 20, 30 of...
A few tens, yeah, perhaps.
Such possible exoplanets. What then? I mean, the holy grail of all this is intelligent life, right? And so, do you focus on those 10 or 20? And if you do, what do you do next?
Again, I wish I knew the answer to this, but I think that we should run things in parallel. Mm-hmm. So, just this past year, through Breakthrough Listen project, $100 million were put into SETI-type experiments, search for extraterrestrial intelligent life. So those concentrate on things like radio signals, which you can perhaps tell that they cannot be formed by any kind of natural processes, and on optical beaming, in case some civilizations want to advertise their presence by some laser beams or things like that they do into space in optical. So those two things, first of all, should go in parallel. Search for biosignatures and those two things. But let's face it, I mean, radio signals, I mean, what radio signals do we transmit into space, even though we are there, right? Very, very little. The things that come from our TVs, which have gone all cable, radar systems, and so on, are extraordinarily weak. And we don't transmit at high power in any way. And if the civilization is really much more advanced, then things are going to be encrypted in such ways that they may be totally unintelligible to us in any case. So I don't think that the chances of those things to discover something are particularly high. Other things that have been suggested, and you and I once discussed this, is they have to somehow generate energy, whatever civilizations are, and that generates some waste heat, and that can perhaps be observed by infrared observations. In particular, if these civilizations are so advanced that they use the entire power of their star or the entire power of their galaxy even, or some mechanism of controlled fusion or whatever. So we should look for bizarre infrared signals, and maybe that will tell us something. But will we from any of those be sure? I honestly doubt it. Yes, if we got suddenly a radio signal that gave us all the digits of pi, I could say, yep, that had to be sent by somebody who knows something. But the chances of us actually seeing there, I see, is very slim. So,
sure. What about this bizarre infrared signal? This was a concept that was suggested by Freeman Dyson, right?
Correct.
In a one-page paper many years ago in Nature. But suppose you do find something, you said bizarre in the infrared. How do you know there's not a black hole lurking in there or something, feeding the dust, the source of energy?
I think it's hard. I think it's hard because you would basically have to convince everybody that you can find absolutely no explanation for what you see. And even if you do that, maybe you are just not smart enough and not thought of another possibility of how to do this. But certainly if you find something that is so bizarre that based on anything you know today about star formation, about dust formation, about accretion onto black holes, if none of that can really fit that signal, then you would say, well, that's something worth following up on.
Sure. Do you have an example? What is so bizarre that your infrared astronomer might rub his hands in puzzlement saying, I can't...
So, for example, you get infrared signals from various dust formations, and you get those in regions that, for example, you have relatively high rates of star formation. You can get also dust formation. But usually, when you get such infrared signals, they are also accompanied, for example, by some ultraviolet signal that signals the rate of star formation and so on. So, for example, if you find some place where when you look at the entire spectrum that you see, it doesn't match any known properties of, let's say, star-forming regions and so on, this would, at least raise some eyebrows, and you would have to think, okay, how can I explain that? But saying it's an intelligent civilization should be more or less your last resort, and definitely not the first.
But again, if we're talking about something on a large scale, like a whole galaxy, then you have to admit one can imagine there are black holes, all sorts of bizarre phenomena that could be mimicking any effect you have in mind.
I have no doubt that that's the case. Uniqueness is going to be a huge problem. Is that a unique explanation? As you know only too well, when pulsars were first discovered, people thought, this may be an intelligent civilization because, there were these regular pulses. Who pulses like that, regularly? Well, spinning neutron stars do that. So you have to rule out every other possible explanation.
So in this, getting back to one of these futuristic telescopes that may find a few tens, as you said, of candidates, is it really worth the effort if it's only a few tens, given that the latest estimates are there are billions and billions of exoplanets out there, and what good is a few tens if you're searching for something like life?
I think the situation is like this. You have to decide what do you do in case of a negative result. I mean, clearly, if you find something, if you spend all this money and you do all these observations and you found this planet that has all this multitude of biosignatures, then certainly it has been worth it. But let's suppose you find nothing. What would you still regard as success? And I think that the only thing you can say is something like this. If I could put some limit that I see as meaningful, and that would be arbitrary, but some limit that I decide is meaningful on the rarity of life that can be remotely detected, then that's an interesting result. So people have decided that 0.1, 10%, is at some level a meaningful statement. Namely, if you have seen enough planets in habitable zones and you've found nothing, then if you will be able to say, okay, then I can say that not in more than 10% of all Earth-like planets in habitable zones around sun-like stars is there a remotely detectable signal, then it's okay. And that's how they came up with these numbers of order 36 or 50.
I guess I don't understand that, because the people who have speculated about life in the galaxy would either say that it's everywhere, very common, or it's extremely rare. And in the latter case, just looking at tens of objects is not going to do you any good. You'd have to survey millions or more. You need a much wider survey.
I would agree, but that's just not possible. So yeah, I mean, the thing is, you see that you could say, since the number of 10% is arbitrary anyhow, and that's more or less what you're saying, I can say, well, I can look at 5, even if I find nothing, then that's it, right? The thing is that with 5 you can really get unlucky. I mean, you want to put a limit, with a certain number of sigmas as to what you're saying about the rarity.
But isn't the other problem here that the template we have is that of the Earth? And I mean, there are just so many other possibilities, aren't there, that life could...
Of course there are, yes. Look, I mean, we're always only as smart as, what we know. I know many people who would say that life has to be carbon-based. And the reason they say that is that carbon does appear to be unique in the periodic table in terms of its ability to form extraordinarily complex chains. So if that is really a necessary thing, then yes, then you would look for something that's carbon-based. That already makes you be a little bit like Earth. Then you also say, okay, I want these chemicals to be able to come in contact with one another, because otherwise they would not be able to form this complex thing. So you need some sort of a solvent. And water turns out to be very good for that. And that's why we're looking for water. Now, could it be that you can make it with liquid methane? Maybe. We don't know. But certainly water has some properties that make it good for this type of thing. So by the time you go through a series of such arguments, you find that, well, they may look a little bit different, and maybe they don't exactly use DNA or ATP or I don't know what, but the general principle of the chemistry and so on maybe is similar, and that's how people operate.
Okay, so let's talk about the chemistry for a second. You mentioned DNA. The RNA world is also commonly cited, but it's my impression that when people try to estimate probabilities of even replicating a strand of genome or something, starting off with some organic mix of whatever, it's incredibly unlikely. Has anyone succeeded in making a plausible case that life could occur somewhere, even rarely?
Okay, so there are people who do origin of life experiments. One is Jack Szostak, for example, at Harvard. Mm-hmm. And, the last I talked to him and I asked him, okay, so when do you think you will have life in the lab? He told me something like 5 years, which sounds very optimistic. There have been experiments here in England which said you don't form all in one place. You form several things and somehow they come together and do things. And by the way, that's an argument for what Szostak is telling me is that he does not think life even on Earth started in a large ocean, because he says you want to have a relatively high concentration of things. So he thinks it started more in like ponds and things that were on the solid surface, on the rocky surface, and not in a huge ocean. So his bet on where life started and where to look for life would be more smaller bodies of water and so on. So, for example, he personally does not think that, if Europa has a huge ocean underneath its surface, then that is a particularly promising place to start life. He would rather have small ponds and so on. So there are these experiments, and maybe in 5 years he will tell me, give me another 5 years, or maybe he will find something. So, but I think that the fact that these experiments exist and that they seem to be making progress. For example, about 15 years ago, he was still struggling to see, okay, from chemistry, how do you produce membranes? Because membranes appear to be important because they isolate what is the interior of a cell from, the outside world. And that now seems not to be a problem at all. So they are making serious progress in these experiments, and we will know hopefully soon enough whether they can actually do it.